Hi friends, today we are going to learn about the how the quantum mechanics origin takes place and why there is a need of quantum mechanics. So quantum mechanics, so what happens in 19th century there were we people used classical mechanics, and classical mechanics is based on Newtonian mechanics, Maxwell's equation and thermodynamics. And this classical mechanics is applicable for the macroscopic bodies which are very large in dimension. But when this classical mechanics is going to apply for this microscopic bodies and for relativistic particle, this classical mechanics fails at that level. So what is relativistic mechan domain or relativistic approach? When the particle velocity is very high at that times, that means the velocity is close to the velocity of light. And if you study the particle behavior at atomic and molecular nature, then this classical mechanics is unable to explain the phenomena. So such phenomena, you can say that atomic spectra, Compton scattering, black body radiation, photoelectric effect. These phenomena are these most prominent phenomena: black body radiation, photoelectric effect, Compton scattering. These are unable to explain by the classical mechanics, and which gives the birth to the quantum mechanics. So how the journey starts? In 19th, the Max Planck introduced the concept of quantum of energy. This is the first concept introduced related to the quantum mechanics. So what he predict that he assumed that there is a interaction of wave and matter, and this interaction is in terms of quanta. So that means the energy emitted is integral multiple of h mu. So energy emitted by the electromagnetic wave is integral multiple of h mu. It may be h mu, it may be 1 h mu, it may be twice h mu, thrice h mu. So it should be integral multiple. It cannot be a fraction. So that is the first concept given by the Max Planck, and this concept of Max Planck, to this concept he assumed that the black body consists of oscillators, and these oscillators emits the energy E is equal integral multiple of h mu. So by this concept he explains the black body radiation. So after that, in 1905, the Einstein gives the idea of the photon. So what Einstein says that by taking the idea of the Planck's, he said that the light consists of a teeny particle, and that particle is known as the photon. And what is the energy of the photon? Energy of the each photon is h mu, where h is your Planck's constant, mu is known as your frequency. So this photon, which is the light particle, which has the energy h mu, and this concept of photon gives to the solution of this photoelectric problem, or photoelectric effect can be explained by using this Einstein's approach of photon. And this was experimentally performed by Hertz in 1887. So this experiment performed by Hertz has given confirmation by the Einsteins in 1905. So this quantum mechanics birth is now starts, and here the quantum mechanics gives the concept of photon, that light consists of particle, that is the photon, and energy of photon is h mu. Then in 1913, Niels Bohr introduced the concept of hydrogen atomic model. So what he predict that whenever the electron transfer from higher energy level to the lower energy level, or when it absorbs energy and goes to the lower energy to the higher energy level, it emits the radiation in the terms of photon, and its energy, its absorb photon or emit photon, its energy is h mu. So he he considered the concept of Planck's and Einstein and form his Bohr atomic hydrogen atomic model, and he says that there is a interaction of there is a emission and absorption of radiation. There is a emission and absorption of radiation by atom when, and it takes place in a discrete amount of h mu energy. So, and this explanation by the Niels Bohr for hydrogen atom gives the satisfactory explanation to the atomic stability and atomic spectroscopy. After that, in 1923, the Compton effect, that is explained by the Compton, and he gives the confirmation that the light consists of photon and photon is behave like a particle. So he obtained the equation for the momentum of that particle when X-ray, that is momentum is h mu c. So what he predict that whenever X-ray photon is incident on the electron, the photons will get scattered in another direction and electron will get scattered in another direction. So by this experiment he predict or he found that the photon has a particle nature. So that is, it gives the confirmation of corpuscular aspects of the light. After that, the de Broglie gives the idea of the particles have the dual nature, that is light behaves like a particle nature as well as wave nature, so dual nature of light. After that, his Schrödinger's and Heisenberg's uncertainty principle, we cannot measure the position and momentum simultaneously. If there is a position accurate, there will be error in momentum. If you measure momentum accurate, there will be the uncertainty in position. Then this Schrödinger's gives the time-dependent wave equations, wave function equation, time-dependent equation and time-independent equation. And these two, Heisenberg gives the that is the Schrödinger's gives the wave mechanical that is the wave matrix approach. Okay, then Dirac gives the concept of bracket operators, and with this it gives the matrix formulation of quantum mechanics. So what we have learned is that those this scientist, okay, so first idea introduced by the Planck, then Einstein, then Bohr, this gives the basics of the quantum mechanics. Then Schrödinger's, Heisenberg and Dirac, this formulated the matrix formulation and wave formulations of this quantum mechanics. So these peoples builds the quantum mechanics basics, and quantum mechanics is the founding basics of our modern physics. So what we have to learn today is that the failure of classical mechanics at relativistic domain and microscopic domain give rise to the birth of the quantum mechanics. And what generally we can say that these black body radiation, photoelectric effect, Compton scattering, atomic spectra, these are unable to explain by using the classical mechanics, but by using the concept of quantum of energy, energy is integral multiple of h mu. By using this concept, you can easily explain the black body radiation, photoelectric effect, Compton scattering, and atomic spectra. So this is the failure of classical mechanics gives rise to the birth of this quantum mechanics. Okay. In next lecture, we will going to study about the black body radiation, photoelectric effect, and Compton scattering. Thank you.